Year 6, I hope you're all safe and well today. I've been really impressed with your arithmetic so far. I know some of these questions this week have been a challenge, they've been getting us thinking, but your determination and your perseverance is really shining through. So please keep that up today. It's very nearly the end of the week, so let's have a final little push over the next few days, and then we can relax a little bit over the weekend. Okay, so we'll start with today's arithmetic. Question number 1 is 27,007. Oh my goodness, Year 6, I can't read this morning. Let's start again, shall we? Question number 1, 2,772 divided by 22. I'm going to use the long multiplication method today. So I'm going to move this out of the way. So I've got plenty of space. Okay, so I'm thinking 22 into 2 doesn't go. 22 into 27. Well, I know that will go once, and that will take me to 22. Now I'm going to find my remainder by finding the difference. So 7 subtract 2 is 5, and 2 subtract 2 is 0. Now I can't do 22 into 5, but I need to bring down the remaining digit, and I can do 22 into 57. Well, I know 2 lots of 22 is 44, and that's as close as I can get. So it goes twice, which takes me to 44. Again, I'm going to find the remainder by calculating the difference using a subtraction. 7 take away 4 is 3, and 5 take away 4 is 1. I can't do 22 into 13, so I'm going to bring down the final digit, and I'm doing 22 into 132. Okay, well I know 22 times 10 would be 220, therefore if I multiplied by 5 it would be 110. It's got to be a little bit more than 110, so I'm going to just try very quickly to multiply it by 6 to see what I get. 2 times 6 is 12, 2 times 6 is 12, add 1 is 13, 132. So it goes 6 times exactly, and there will be no remainders. Okay, that's question number 1 for today. If you need to pause the video, please do so, because I'm going to rub this out so we've got enough room for question number 2. Okay, question number 2 then. We're taking our fraction thinking a little step forward this morning. So we want to work out 4/5 of 450. Now I'm just going to draw a bar here to represent our 450. Some of us have been finding these fraction questions a little bit tricky, so I'm hoping this visual will help you. So this bar here is the same as 450. I want to know what 4/5 are. Now I could split 450 into fifths. I know it's into fifths because this means 4 out of 5. So 1, 2, 3, 4, 5. And I want to know what 4 parts, or 4 out of 5, is worth. Now to solve this, I need to know what 1 part is worth so that I can find 4 parts. Now if I've shared 450 into 5 parts, that means I'm dividing by 5. Now I can do that quite quickly mentally because I know that 9 times 5 is 45. So 450 divided by 5 will be 90. So each of these sections, just rub these out again, Year 6, each of these sections will be worth 90. Okay, so I've split 450 into 5 parts. 1 part is worth 90. Okay, so now we know that then, how can I work out what 4 parts is worth? Now I could do 90 add 90 add 90 add 90, or I could do 90 multiplied by 4, which I know, if I ignore the 0 for now and make it 10 times smaller, 9 times 4 is, that's right, 36. Pop the 0 back on, make it 10 times bigger, 360. Now that's one way of calculating this answer. Others of you may have noticed that all you had to do was 450 subtract 90. You might not have done the multiplication part, which is fine. Okay, I've multiplied it because that's a method we've been using at school for similar fraction questions. But if you're starting to make links in your fractions and your learning, you may have realised that you could have just subtracted the 1/5 to be left with 4/5. Either way, you're going to still have 360 as your answer. Okay, so question number 3. We've got a subtraction question. So I've set up the formal method of subtraction here. 93,725 subtracts 75,116. Okay, so we start in our ones with 5 subtract 6. I need to exchange to be able to do that. 15 subtract 6 is 9. 1 subtract 1 is 0. 7 subtract 1 is 6. 3 subtract 5, again I need to do an exchange. 13 subtract 5 is 8. And 8 subtract 7 is 1. 18,609. Okay, question number 4 then. We've got a percentage question. It's been a couple of days since we've done one of these, so we'll go through it nice and slowly together. We want to know what 55% of 400 equals. Okay, well let's think about 55 to begin with. I know I can partition it into 50% and 5%, which is handy because I know how to find 50%. I know 50% is the equivalent of a half. It's the same or equal. So to find a half, I divide by 2. So 50% of 400, I need to divide 400 by 2 or half it, which will be 200. So I found the 50% now, and now I need to find 5%. Well, I know how to find 10%. So 10% I would have to divide 400 by 10, which would be 40. So if 10% is 40, I know 5 is half of 10. So to find 5%, all I need to do is half my 40. And half of 40 is 20. Okay, so I know now 50 and 5% will total to be 55. So I need to total together this side as well. 200 add 20 is 220. So therefore my answer is 220. Okay, let's have a look then at question number 5. 82.6 multiplied by 6. Okay, so I've set up my formal multiplication method here. I'm going to start over here with 6 times 6, which is, that's right, it's a square number, year 6, 36. Then I put my decimal point in. We're into our ones now. 2 times 6 is 12. Add our 3, that's right, 15. And 8 times 6, add the 1 you've carried, 49. 495.6. Okay, that concludes then the first part of our arithmetic today. We're going to move on to our questions. Okay, number 1 then is a green question, which we should all be confident and happy with answering. It says, write the missing number to make this division correct. Let's have a look then. What can I see? What do I already know? 0.3 divided by something equals 0.03. Okay, now some of you I know will look at this straight away and you'll know exactly what it is. Others of you may need to use a place value chart. And we're really familiar with drawing these at school, and you can see that I'm getting one ready for us over here. Now they only take a couple of seconds to draw because they don't need to be neat. I mean, they need to be neat enough that you can use them, but they don't need to be exquisitely beautifully neat. They're a jotting or a drawing to help you. Put my decimal point in a different colour there because we know the decimal point comes between the ones and the tenths. Okay, so I'm going to put my original number on here, 0.3. Perhaps green wasn't the best to use. Does that stand out? It stands out a little bit more, I suppose. Not a huge amount, to remember that. Okay, so our answer is 0.03. Now, straight away, I can see that all of the digits have moved over in my place value chart by 1 place. That tells me that the numbers, I can see the numbers smaller straight away, but it's been divided by 10. Because when I divide by 10, I'm making the number 10 times smaller, just as I can see that they've done here. So my answer is 10. Okay, on to our amber question now, which everybody in our class will be able to have a go at. There may just be 2 or 3, maybe even 4 people this morning, 5 people at the most, who will just have to think about this one a little bit harder and really think about what they know. So I'm going to think about using UDC, underline and understand, draw a picture. Well, they've got a picture here for us, so I might do some jottings on there in a moment, and then possibly some calculation, we'll see. This chart shows the number of different types of big cat in a zoo. So let's have a look at the chart. We've got cheetahs, jaguars, lions and tigers. There are 20 big cats in the zoo altogether. Okay, I'm going to look at this chart then, and normally I'd be sort of doing a drawing. In this case I'm going to do a jotting. Now straight away my eyes are drawn to the cheetah. Now I know that this represents 1/4. Okay, I can see the tiger is about 1/3 possibly. The jaguar is less than 1/4, so less jaguars than cheetahs but more tigers. Lions have the smallest section, so I would suggest that there aren't as many lions as the other 3. Okay, so that's kind of what I'm looking at and what I can see that I know. Here are some statements about the chart. Tick the statements that are true. Okay, there are more cheetahs than jaguars. Let's have a look then. So does cheetahs have a bigger section than jaguars? Yes, it does. So that is true. The total number of lions and tigers is 10. Okay, well I'm looking at the lions and the tigers. And I'm looking at the cheetahs. Now the cheetahs is 1/4 of the big cats, so 1/4 of 20. Now to find 1/4, we know that's the same as dividing by 4 or halving and halving again. So half of 20 is 10 and half of 10 is 5. So therefore there'd be 5 cheetahs. Now, if I think about tigers, this looks like about a third to me. And about a third of 20 is 6.666 recurring. So already I can see that that can't be correct. If there's 6.66 recurring of tigers, no, it's not going to be 10. There's simply too many animals. So that can't be true. 1/4 of the big cats are cheetahs. Yeah, we already worked that out, haven't we? So yes, that is true. There are more than 5 jaguars. Well, that's not possible because I don't know. I just don't know, do I, Year 6, what this represents? And I don't know the other amounts confidently enough to say that that is true. So hopefully you've ticked those 2 boxes and you're feeling happy and satisfied with why you've ticked them. Okay, question number 3 then. Going to make a little bit more room for us. Here we go. So using UDC again, I'm going to underline and understand this question. I'm going to do a drawing. Well, there's already a drawing here, so I might do some jottings to go alongside it, and then I'm going to calculate. So this is a diagram of a vegetable garden. It shows the fractions of the garden planted with potatoes and cabbages. Let's have a look then. So potatoes is 2/3, cabbages is 1/4. The remaining area is planted with carrots. So we don't know what this is worth. What fraction of the garden is planted with carrots? Well, actually, we don't know what the total is of these because that bottom number means what it's out of. So 2 out of 3 and 1 out of 4. Now, they're not common denominators. So at this point, I don't know what the common denominator is. I don't know what it's out of. Now, I'm going to start by thinking about what is the total amount so far. If I was to add these 2 together, I could find this part. Before I can add them, I need the common denominator. So then once I've added them together, I'd know what was left of the common denominator for the carrots. Okay, so let's find a common denominator then to be able to add them. So I know 3 times 4 would be 12. And I know 4 times 3 would be 12. And then I'm going to have a common denominator. Now, whatever I do to that denominator, I've got to do the same to the numerator, the top number. And 2 times 4 is 8. Again, I've got to do the same here. So 1 times 3 is 3. Okay, now I can add them together. I never add that bottom number or the denominator. That stays the same. 8 add 3 is 11/12. Okay, so I know these 2 parts, the potatoes and the cabbages, they would total 11/12. So out of the whole thing, I've only got 1/12 left for carrots. Okay, there we are, Year 6. We've solved it. 1/12 is carrots. Right, hopefully, Year 6, you've enjoyed today's arithmetic. Please send your answers to me in Class Dojo so that I can have a look at how you're getting on. And as always, if there's something you've not been sure about today, please let me know on one of our Zooms and we can go through the answers together live and we can share your strategies and your methods and unpick any problems that you've come across. Have a wonderful day, everybody, and I hope to see you very soon.